So, good morning. Welcome to Thursday, March the 18th. Today, we're going to be talking about something called energy pyramids. And as I say here, it's just another way that we can represent food chain and a food web. And it does the same thing a food chain and a food web does, which is to show us how energy moves through an ecosystem. So let's look at the slides. All right, then let me get rid of these guys down here. There we go. All righty. So let's see what's on. Oops. So again, there's our teak of understanding how energy moves through systems, whether you're looking at a food chain, a food web, or today you're going to learn about energy pyramids. And if you understand the food chain, then you're going to understand this energy pyramid. Alrighty. So when we do energy pyramids, if we were doing this in class, I'd have you, draw this pyramid like this, and we would write information in it. But in this case, I'm going to be the one, or you're going to observe me filling in this energy pyramid. But here's some examples that, I found online that show energy pyramids as well. Basic construction of any energy pyramid is that the producers are at the bottom, always, okay? And then the first level after that, so here's the producer level, and then after that, everybody else is consumers, because that's how it is in real life. And if you remember the big food web that had the marine scene and the two humans on it and stuff, we had two producers and then everybody else was consumers. So that's true here as well. One big difference though is that there's a lot more plants than there is animals, okay? We measure things in what's called biomass. Like if you took out every plant on a square block or a mile out in the country, and if you took out every plant and you weighed everything, the trees, the grass, everything, the bushes, and you weighed how much that just weighs in pounds, and you would compare it to the same thing for the animals that live on that 1 square mile, there's always going to be more plants. And that's a good thing. We want there to be lots of plants to be able to eat from, because it supports everything else. And this pyramid is a really good, graphic representation, because this is the support. This is what holds up everything else. So at the bottom, always producers. Then we have primary, secondary, tertiary consumers. Okay, so it says an energy pyramid is an image or graph showing the flow of energy at each trophic level. Trophic just means eating, so at each level in an ecosystem. The width of the bar, how wide it is, this bottom line represents units of energy available. So there is more energy in plants, in the producers, than there is in the animals. And you notice it starts getting smaller. Every step it gets smaller. So there's lots of energy down here. Once the animals start eating it and pass it on by someone eating them, it becomes less and less energy. And you'll see an example of that as we go along. But it's just another way to do this, show the flow of energy. Alrighty, so here's the coastal food web that we've been kind of looking at and working with and stuff. So if we're going to fill in, if I ask you, okay, take this food web and fill in that pyramid, you have to know where each of these critters and plants, where they go in a pyramid. So if we look at this, we first have to find the producers. And I think we've already established that these two are the producers here. They are going to go at the bottom. They are.
Miss,
Yes.
I think the screen sharing froze or something.
Oh, okay, honey. Hold on. No, it's y'all are still just looking at Celine. Yeah, that's what it is. Right there? Are we good? Yes?
Yeah, that one's working.
Okay, thank you. Now, everybody's going to know all day what happened. Let me start back here by just, again, showing these food pyramids are typical of what you see, where the producers are always at the bottom. And then from there, everybody else above there are going to be consumers. They either have to eat plants or they have to eat animals to survive. And this is just another way of showing a food chain or a food web, okay? And how wide the bottom line is, it should kind of, you know, we made it to say, hey, look, this a pyramid fits really well because the plants go down here. They're the foundation of everything. It's bigger down here. That represents how much energy. As you go up the pyramid, there's less energy. So if an organism eating right from the producer gets a lot more energy than someone eating, whoever the apex organism is up here at the top. There's more energy down here. As you go up, less energy gets pushed up, and we'll see. I'll show you an example of that. Okay, and then this is where I was starting with the coastal food web that we had been using and stuff, and use that as an example of how you can take this and put it into an energy pyramid. So we established that these two were the producers. They're the only plants. So we're going to put them here at the bottom. Again, this is the foundation. This is what holds everything else up, are the plants. And we know that plants are producers. They're autotrophs. They make their own food. The only energy they take in from anywhere is from the sun, and the sun is not an organism, okay? So they take energy from the sun, they undergo photosynthesis in their little leaves, and they make glucose, and they store it in their little glucose Tupperware in their bodies until they need it to grow more roots or leaves or whatever. So this first layer are the producers, the plants, and autotrophs mean they make their own food. Auto means self, and troph means feeding. So they feed themselves. They don't need nobody. All the animals could go away and plants would be fine without us. Okay? So these guys that I have circled here, they're going to be on the next level. And can anybody guess why I'm putting them on the next level above? Come on, don't be shy. Wake up. Brandon, since you're here, why do you think these are the next ones above in the next level? Because they're the ones eating the plants. Oh, beautiful. You said because they're the ones eating the plants. They're the first ones eating the energy from the plants. So remember, primary means first. So they're the first ones who are eating the energy from the plants. So these guys... Oops. So these are one. So the sea urchin is eating the kelp, and it's also eating phytoplankton. Mussels eat phytoplankton. So these are primary consumers. They're the first ones eating the energy from the plants. Okay, so we would put them here. So the first heterotrophs to take it, and hetero means that they have to consume other organisms in order to survive. So the first heterotrophs that take the producer's energy are the first ones in line. So they're the primary ones. So one thing I want you to notice is that the arrows from the producer showing the energy goes directly from the producer to that primary consumer. Okay? And so the producers are down here. We just kind of moved the paper up. So there's my primary consumers I just put in. And then it says second in line to get energy from the producers, from the plants, are these guys. And we call them secondary consumers. Can I call you back, sir? Okay. Oh, you're right. I do have it off. Off. Yeah, and they're far away. Yes. Uh huh. Okay. Thank you. Bye bye. Alrighty. So we have our secondary consumers, and they're the ones who are second in line to getting the energy from the plants. So they get it though they get it via the primary consumers. They got the energy from the plants. Now the secondary consumers are eating them, and they're getting energy as well. It started with the plants, but remember, these primary consumers, like the sea urchin and mussel, they got to live too. They got to live their best lives too, and they're going to do that. They're going to use some of that energy they got from the plants by, moving, reproducing, whatever else sea urchins and mussels do for a living. They're going to use up some of that energy. So the secondary consumers, they're going to get some energy from eating the sea urchins and the mussels, but not as much as they got from eating the plants. So, sorry, I went up. So when these are the primary consumers, our secondary consumers would be the ones that eat your primary consumers. So we have the sea otter, the fish, the crabs, and the sea stars. And all you have to do is follow the arrows. Remember, it's all about the arrows. So here we go from the producer to the primary consumer, secondary consumer. He's number 2. Primary consumer, where does the arrow go? To the secondary consumer. And the same here. Here's our primary consumer. It gets eaten by the crab. He's the secondary consumer. Okay? And that's all you do. You just follow the arrows and count. He's the first one, he's the second one. And as you can see, there can be even longer chains. So again, our secondary consumers were all of those 4 that are eating the primary consumers. And then you can have a tertiary consumer. They're just third away. And guys, really, all you have to do is count. So here we count 1, 2. Notice that's the same as the number of arrows. 1, 2. Yeah, I get to the sea otter. If I count 1, 2, 3, I get the sea otter as well. So an organism, a sea otter is not just a secondary consumer. It can be a tertiary consumer. Or if that sea otter eats kelp as well, he could have been a primary consumer as well. So none of it is like you are only a primary consumer. And now there are some, like cows pretty much only eat grass. They're going to be primary consumers, always. But there are many, many organisms on our planet that are omnivores, who eat some of both, who eat plant and eat animal matter as well. And then at the very top, we have the shark. And this is the third consumer level. It's the tertiary consumer. And they're heterotrophs as well. They have to eat other organisms in order to survive. So here we have the complete picture. So we just you saw that same food web that we have been using and put it into this order. But again, that sea otter, we could have put him as a secondary consumer and a tertiary consumer. So nobody in nature really has, just one place. Alrighty. So let's start with this one.
Every day in nature, energy is being transferred. Energy from the sun is transferred to these plants. And then insects may receive energy from the plants. And then a snake may receive energy from an insect. An energy pyramid is a display of energy flow in a community. The different levels represent different groups of organisms and where they receive energy. Welcome to Moo Math and Science and Energy Pyramids. Let's take a look at an energy pyramid in a typical ecosystem. You will find producers at the bottom of the energy pyramid. Examples of producers are plants. Plants are autotrophs because they use sunlight and photosynthesis in order to produce glucose, which can be converted to energy. They do not rely on other organisms for energy. Plants take sunlight plus carbon dioxide and water to produce glucose and oxygen. Plants make up the base of an energy pyramid. The next layer includes primary consumers. These organisms are herbivores because they eat producers or plants. Examples are insects, cows, horses, and any other organisms that live exclusively on plants. The next level includes your secondary consumers, which include carnivores or omnivores. Carnivores consume primary consumers, and omnivores eat producers and primary consumers. Examples include frogs, lizards, many snakes, and many birds. Above the secondary consumers are tertiary consumers. Tertiary means third level. They consume secondary consumers. This level includes carnivores. Examples would include wolves, lions, and this hawk. Each layer of the energy pyramid is called a trophic level. And as you move up each trophic level, 90% of the energy is lost, much of this to heat, and only 10% is transferred to each layer above it. If you'd like to know more about energy pyramids, this playlist will help, and as always, Moo Math uploads a new math or science video every day. Please subscribe and share.
All right, so just a real nice kind of simple explanation of pyramids. And this next little video is, it's a little crazy. It's a computer-generated voice thing. And so it literally, I don't know. The translation's a little crazy and stuff, but just watch. We watch this one every year.
From www.makemegenius.com. If you want to see more science videos, go to www.makemegenius.com. Oh, yeah, it is free.
I was so tired and hungry. I wanted energy to continue. Do you know why we need food? Okay. You know we need food to get energy. Energy is required by living being for growth, also for movement. We need energy. Similarly, when species reproduce, they need energy. Also, as grow up or grow old, our old tissues get damaged or new cells are produced. This process also needs energy. Now, from where this energy come from? Most of the living species use sun's energy. This energy is transferred to body via food they eat. Sun gives light energy, which is used by plants to make their food by photosynthesis. These plants are eaten by primary consumers and energy is transferred to them. Now secondary consumers eat these primary consumers and energy is transferred to them too. So does giraffe get all the energy from plant which plant gets from sun? Or does lion gets all energy from giraffe which giraffe gets from plant? The answer is no. Actually, 90% energy is lost when it passes from one part of chain to other. Like 90% energy is lost when giraffe eats plant. Similarly, 90% energy is lost between lion and giraffe. Look at this pyramid. It is called energy pyramid. This shows that energy available becomes lesser and lesser as we move on the top of food chain. To understand energy pyramid, let's assume plants absorb 1,000 units of energy from sun. When giraffe eats it, 90% energy is lost, so giraffe only gets 10% of energy. This means energy transfer from plant to giraffe is 105 of 1,000 units of plant energy, which is 100 units. Now when lion eats giraffe, 90% energy is again lost, and lion gets only 10 units of energy. So now you know more about food and energy. Can you give me one more bite? Please give me one more bite. You already have so much energy. I need more food to get more energy. Sorry, man.
All right. So
Now
again,
you're go-
we pass on the energy. That's how it's set up in nature. Alrighty. So I hope you see how that translates from a food. We could have done a simple food chain and put it right in there. But you could see how we can do food webs as well. So we have today a discussion, our exit, and then you have your assignment to do as well. Let me get rid of these monkeys. The assignment to do as well, and then you're done for the day. So please do the work before you leave. That way, if you have any questions or yesterday, the one y'all did, there was 2 possible answers for one of them. And I think if everybody would have left and not told me, then we wouldn't have discovered that. So that's even another greater reason. And if you need help, then I can help you. So let's go ahead and go into our Thursday lesson and take care of that assignment. There's your discussion. Thank you. Some of y'all have already started working on that. And then there's the energy pyramid assignment. And everything should be open. Yay, thank you. And guys, remember, you have 3 attempts. If you don't make 100 the first time, take it again. I mean, it's like you're leaving money on the table. Like if I put $100 bills and 20s and you just took one instead of taking them all. Take it all. Get the 100. Let me know if you have any questions or if something's not working for you. And when you're done, of course, you are free to go. I hope y'all have a happy, happy day.